Very excited to be able to talk about a topic near and dear to my heart today. That's transparent and reproducible analysis as a key component of data acumen. So I'm Nick Horton from Amherst College, and my plan for the next 40 minutes or so is to step you through what I mean by data acumen and how that relates to some of the conversations in the TIR Symposium. I want to briefly begin with some acknowledgements. Some of my work on this talk was funded by the NSF grant I'll be talking about a little bit, the Data Science Wave. And I've been influenced by so many people that are listed here, many others, and also the Project TIR folks and the Sheffield Methods Institute for the invitation. I really thank you for this opportunity. I've so appreciated each of the talks to date. I'll talk a little bit more about that. But the Sheffield Methods Institute kind of strikes really near at home for me as well, because my dad, John Horton, was a University of Sheffield graduate. My grandmother lived there her entire life, and it's a place near and dear to my heart. So the plan for today is I would like to kind of talk a little bit briefly about the TIR Symposium to date, then launch into a definition of data acumen and how it relates to the topic of the symposium, that of reproducible research. I'd like to talk briefly about some initiatives to help bolster data acumen that complement what we've heard about so far, as well as to discuss this data science core, the DSC-WAV project, and then finally have some closing thoughts. So the TIR Symposium, here we are, kind of partway through. It's a very creative virtual event. We have these two-part presentations followed by Q&A over kind of March through May. I really enjoyed the Passover Easter thinking gap to give us a chance to catch our breath. But it's really a slow food metaphor that's well suited to the pandemic. It allows us to watch at 1 time or 1.25 speed each of these individual keynotes and presentations, and then to kind of have the opportunity to share Q&A and follow up from that. I think that model has been a remarkable one that really works well in a pandemic or at other times. I think this connection we have with the European and the project here, primarily US-based, has been just fabulous. As I stepped through each of the presentations, there were a lot of wisdom, a lot of things I got from each one of them. Nicole's keynote started us off on teaching replication, and it was really interesting to see how the aspects of qualitative replication could be scaffolded as a pedagogical approach to help students understand the material as well as get a deep and fundamental understanding of replication, the practice, the motivation for it. That really kind of, I think, got us off on the right question of, even thinking about replication versus duplication. Amelia's talk was entitled Consistency is Key, a case study in our syntax. And what I took from that was really how you could be using tools like R Markdown in RStudio to scaffold more for their students so you can get further, faster in various ways. As well as a lot of the work that Amelia's been doing over the last couple of years about code reading and code comparisons that really kind of help think about what are going to be optimal approaches for students to be able to develop what I'll describe as full data acumen, this aspect of data wrangling and syntax in ways that I don't think we've done nearly enough of so far. Nicholas Bussberg's talk was incorporating an accessible reproducibility workflow into entry-level courses. I loved the lab notebook metaphor, as well as the mantra that I've really taken on, and as I've shown the effectiveness in our program. I teach at a small liberal arts college, where reproducibility is part of all courses, where we start simple and build on a common framework so that it's expected. And I think that kind of approach is really helpful and complements some of the efforts that we see in graduate school with Nicole and others. Jessica, coming from the psychology standpoint, provided a really great talk on a practical approach to teaching reproducibility, as well as improving your own research. I think kind of these time-saving hacks are eminently appropriate and valuable. She stressed this idea of do-it-again ability is what we want our students to be doing. And the way that she has very creatively done this is by using some in-press or recent papers, having the students reenact the study, albeit without the kids, in developmental psychology or other kinds of areas, and also using this as a way to kind of focus in on the kind of work you want to be doing and helping students engage in that. And this kind of aspect of, rather than just having people write a method section, really kind of work through that in an experiential fashion. Phil McAleer's presentation was entitled Creating a Curriculum Centered on Reproducible Research. And this really came from the humbling experience, I know this all too well, that students were fine if the data were in the right format. They could kind of proceed with whatever it was in section 5 of chapter 14. But if it was out of context, if the data were in some other format, they could get stuck really, really pretty badly. And so this approach, dealing at scale, that's happening in the SciTeach our repo that's listed here, and some other approaches to introduce, reinforce, and work towards mastery. And again, doing this in large numbers at his institution. So together, all of these have really given me hope and some excitement about how reproducibility is playing out. And it's not just a kind of a fringe thing, but starting to have a big impact. That being said, I think there's a lot of work to be done, and where these things are disseminated is not nearly where we need to get to. Another thing that was happening around the same kind of time was the Toronto Reproducibility Workshop. I've given the link here to that because, again, all the talks and various parts and pieces of that were recorded. This is organized by Rohan Alexander and colleagues at the University of Toronto. But again, they were thinking about evaluating reproducibility, practices of reproducibility, teaching reproducibility. And again, there's a lot of back and forth, a lot to be learned from what they've been doing, how they've been organizing this. And again, trying to pull this together in a pandemic and figure out ways of sharing those resources, not everyone having to build everything from scratch. So I was asked to kind of give a high level, kind of like, why should we care approach. And I think the place I wanted to start is the National Academies report, the 2018 Data Science for Undergraduates Opportunities and Options report. So this consensus study, funded by the National Science Foundation, is available for a free download at the URL I've given here. And there's a number of parts and pieces that I think that relate directly to the topics and things we've been discussing in the symposium. So first, the report, came up with a number of recommendations and findings or insights. So there must be multiple pathways for undergraduates to study data science. This was thought of in a very flexible manner. The study didn't actually define data science. I think that was smart on their part, though they did come up with something, this data acumen, that I'll talk about in a minute. The undergraduate experience, and again, this was focused primarily at undergraduate, though a lot of the work we're seeing now is beginning in kind of middle grades, kind of pre-secondary, primary education, moving to secondary, as well as a lot of stuff happening in graduate programs. But that it's important to be promoting diversity, demographic and intellectual, in the students that are served. And then there are some core competencies that all data science students should have. And if it's at a little level, I'll call that data literacy. All students need data literacy. But those who are going deeper, and this includes a number of students in the social sciences, obviously who have a little bit more depth, like a minor or the equivalent like that, should develop what they defined as data acumen. And obviously ethics is part of this. There's some other parts of it as well. So this data acumen requires exposure to key concepts in data science, real-world data and problems that can be used to reinforce the limitations of tools and ethical considerations. And so there were 10 areas that laid out in this finding of the different components of data acumen. These included kind of fairly traditional mathematical, computational, and statistical foundations, data management and curation that includes aspects of reproducibility, data description, data modeling, workflow, communication and teamwork, domain-specific considerations, and ethical problem solving. So for me, I'm going to focus really on these 5. These are bolded areas, my bolding, where I think there's a really direct connection with reproducibility as we define it broadly. I also think of many of these things as what I would call previously statistical practice aspects. That may be less the kind of things people may have learned on the street, but were really critical to effective statistical analysis. Let me step through some of these. Many of them I'll go over fairly quickly. Obviously, there are key mathematical concepts, skills that are important for people to be doing and to have as a kind of a foundation. Again, this is primarily thinking about people majoring in data science or something like it. Computation is really important, really aspect of algorithmic thinking and abstraction. Whole bunch of statistics as part of that, some of it more traditional, some of it kind of really focused on observational or found data. Data modeling is really important. These are kind of topics that I thought were a little less germane to the reproducibility part. There's certainly key parts of data acumen. Data description and visualization. So now we're starting to get to something that I think does kind of relate directly. Exploratory data analysis shows up a couple places in terms of these data acumen components. But I think when we think about exploratory data analysis, that gets us to this data science cycle that we want to be supporting for people. And so that becomes a point where reproducibility is important. So data management is certainly one of the areas where data acumen relates very directly to reproducibility. When we think about aspects of establishing data provenance, data preparation, data cleansing, data transformation, data management, what I would call data wrangling, missing and conflicting data, all these parts and pieces are kind of, I think, central, and again, have been the type of things that historically people have not focused on so much in the curriculum and really require a lot of scaffolding and support to be effectively done. Again, I think the tier protocol has been helpful in that and some other approaches in there. There was a kind of a highlighted aspect of workflow and reproducibility that are important for all students in their data science programs. These include aspects of reproducible analysis, documentation and code standards, version control systems, and collaboration. And so those kind of start to think about it holistically and more kind of software engineering types approaches, but really thought of for data analysis. Communication and teamwork. I really hate when this is called soft skills. I think these are career success factors, but we know that data science and much of the kind of work that's now happening is a team sport. So being able to do clear and comprehensive reporting, as well as kind of conflict resolution skills, and again, getting things down on paper or their virtual equivalent in electronic format is really important for people as they're thinking about these more complex projects. Ethics is critically important for all data sciences, and I think it is also a big aspect of that. We've heard some of that so far during the symposium for data science, that the responsible conduct of research demands, at a minimum, reproducibility, and that students would have some understanding of these ethical precepts is going to be really critically important. So those are the different components of data acumen. And again, I think the big concern is that we've often not focused on them nearly as much as we have on modeling and inference, certainly on the statistical side, and that the tools haven't, quite frankly, been effective to be able to kind of do the types of teamwork and reproducibility. But again, we need to kind of think about teaching and assessing this, and that's where further work is needed. You may have seen also the National Academies report in 2019 on reproducibility and replicability in science. And I think this has some useful aspects for us, both for best practice for science, and then also best practices for how we think about teaching. So recommendation 4.1 from this talked about how researchers should convey clear, specific, and complete information about computational methods and data products to enable other researchers to repeat the analysis. And then this should include the data, study methods, computational environment. So a lot of work we need to do to kind of port complex computational environments, but we're making progress with that. So this would include either the input data by using extension or intention, as well as intermediate results and output data for any steps that are non-deterministic. Can it be reproduced in principle? A detailed description of the study methods, along with its computational steps and parameters, as well as information about the computational environment. Recommendation 6.6 from the 2019 NASEM report talked about the role of stakeholders' role in improving computational reproducibility, and that includes many of those who have been participating in this, but that educational institutions need to educate and train students and faculty about computational methods and tools to improve the quality of data and code and to produce reproducible research. Again, there's a lot of skepticism here, there, and everywhere. Science is under attack in various places. I think it's really important that we make sure that we are addressing some of these questions as they come up and meeting these challenges put forward by some of these reports. So what I want to do for my keynote is to talk very briefly about some of these questions about why they're so important, what we want students to learn about, what are the skills we need them to master, what are best practices, how can we think about incorporating these not only in the college and university curricula, post-secondary, but the K-12, the what I would call the secondary or primary. And then last but not least, how do we assess how effectively students are using these methods? So the way I want to start with that is to kind of talk a little bit about how I've been approaching these through my work on some of these efforts, like the National Academies Data Science for Undergraduates, but also kind of how it relates to some initiatives people are aware of or that are current research. The tier protocol 3.0, I think, is really useful in terms of getting people to think about file structure, file naming, and just to kind of make sure that things are put in a way that isn't just a kind of a random mishmash of kind of files and structure, to allow that kind of have some structure to kind of help scaffold that in various ways. And this was, I think, started appropriately with substantial research projects, but I think now, the work that's happening is to build a developmental progression across the undergraduate curriculum. And again, you see great examples of this from the soup to nuts exercises that start kind of early with little bits and pieces. And again, that builds on some of the advice we've heard from earlier talks. Start small, but expect it throughout. I had the pleasure of working with Ben Baumer and colleagues on a paper that talked about integrating R Markdown in our studio as a reproducible analysis tool into introductory statistics. And this included reports of student experiences from Duke University and Smith College. Good news was the interface in R was bad enough that this was really thought to be an improvement for many students, that their frustrations were low, and of the frustrations that we reported 7 years ago, many of those rough edges have been rounded off. What we found here was that, that R Markdown made a welcomed improvement to the traditional cut, copy, and paste workflow. Students left the course equipped with functional skills that'll help them in any future quantitative endeavor. And I think for me, the motivation is you've done this kind of report and analysis of a clinical trial, and your boss comes in and says, oh, subject 11 didn't consent. Can you please rerun the analysis without them? In one case, that's going to be really hard if it's a cut and paste workflow. And I think students start to see the power of that, particularly as we have them iterate and improve their work over time, which is really how science works in the real world. Recently, I published a paper with colleagues on the ways of incorporating version control. And so GitHub and related tools like that have been commonly used as a way of scaffolding and organizing as version control structures. This paper, which is available from the Journal of Statistics and Data Science Education, provided student experiences from Amherst, Brown, Duke, and the University of Edinburgh. And what we found in there was that teaching reproducible analysis in the statistics curriculum helps to make students aware of the issue of scientific reproducibility, also equips them the knowledge and skills to conduct their future data analyses reproducibly, whether as part of an academic research project or in industry. And I think what we've really been finding is that if you're careful about doing this, you can adopt Nicholas Bussberg's start small, build little parts of it and have people work, to develop more mastery over time as it gets reinforced. And that means that we don't need to devote so much class time in our upper level classes if students would have gotten this experience earlier on. And that there are ways to be doing that by just minimizing the cognitive load. We found that use of version control helps reinforce the notion that statistical analysis typically requires multiple revisions, as students can review their commits to see all the updates they've made to their work. Desirable side effect is that because students are periodically submitting their assignment as they work on it, there is less pressure of the final deadline where everything must be submitted in its final form. And again, this idea of students going back, updating, editing, changing, improving based on feedback or peer reviews, I think is exactly the kind of things we want to be doing in our project-based courses, and GitHub really facilitates that for us. So I wanted to talk briefly about the data science wave, this Wrangle-Analyze-Visualize project. This is an NSF-funded initiative from the Harnessing the Data Revolution project, and the Data Science Core is a workforce grant thinking about the skills that the next generation of students will need to succeed in the workforce. The website for the project is available here, and this is a collaborative project with the 5 colleges, Amherst, Smith College, Hampshire, Mount Holyoke, and UMass Amherst, as well as 3 community or 2-year colleges that provide associate's degrees, Greenfield, Holyoke, and Springfield Technical Community College. We have the great pleasure of working with Andy Ziffler and his team, the University of Minnesota, working on the assessment for the project. So one of the parts and pieces in there that we've been doing with the DSC-WAV, and really goal 1 of that, is to have undergraduate students work on data science for social good projects. So, typically these are messy data from some nonprofit organization. For example, the Health Equity Network in Western Massachusetts looking at health data. Girls Inc. is a advocacy program for young women in the Pioneer Valley. I've been working with the nonprofit Valley Bike Project, which is a bike sharing system that's been targeting kind of working in historically underserved areas. So the undergraduate students engage in these projects over a semester, working with clients to really give them a sense of what it means to be doing data science for a nonprofit organization. So how have we structured that? Well, what we found is that it's really difficult for students to be kind of working on these more complicated projects without some structure and supports, scaffolding to make that work. So we've been exploring the use of Agile. This is a development framework that was designed for software engineers, and Scrum, a particular version of that, and really doing that for undergraduates. So how does that look? We wrote a paper to describe the program, which is available from the Harvard Data Science Review. This was motivated because many of the courses and programs that we have at our schools teach students relevant data science skills. And that is really important. We need that foundation in the technical knowledge and the frameworks. But we can only expect coursework to develop students' data acumen so far. It's unclear whether coursework alone, even with project-based work, is enough to provide students with the experiences with data and computing they need to be successful in tomorrow's workplace. And for this, I'm really thinking that data science and a lot of the work people are doing more for is not going to just be an individual effort. It's not going to be some one person doing something and that's going to be it. It's going to require collaboration and coordination that we've not necessarily included in our courses. It's really difficult to scale that. We've talked about some different approaches where there might be kind of smaller projects or larger projects, but these kind of bigger things we find as we start moving into more real-world projects. So the way that Scrum works is that work is organized into a series of what's called sprints. And these short sprints, typically 3 weeks or so during a semester, are a way of breaking up larger tasks. So subtasks are organized in some fashion. We have something called a backlog, which identifies priorities for that stage of the analysis. So it might be kind of preparing the data in some format, or creating some kind of dashboard, or doing some intermediate data wrangling. So the team and the stakeholders, and this includes the faculty member, advisor, as well as the liaison from the community organization that's providing the data, they'll meet regularly to share results and make adjustments in advance of the next sprint. So they're kind of retrospectives and demos as part of these sprints. But during the sprint, there will be things called a kind of regular Scrum stand-up. And during that time, there would be Kanban project boards. So these are kind of to-do lists and boards where people can be shuffling what kind of projects, what kind of parts of these tasks are currently active, are implemented using, say, Trello or GitHub projects. And these are used to review the backlog of tasks, team progress for these things. As work is done, as analysis is created, as reports are put together, or data wrangling is happening, there's code review that's happening on a regular basis. We've implemented this using GitHub pull requests, though there's different ways of kind of organizing it. But that code review is really important, as it means that there's another set of eyes, and again, this coordination and collaboration that was listed as part of the data acumen earlier. So again, as I said, code review is a regular part of the process, and the idea behind that is getting people going back and forth. Not easy. We've been doing some of this in our courses with some peer reviews and the like, but this is a kind of a higher level of accountability that we want to instill with the students to kind of ensure that their work is at an appropriate and high enough level. So the goal of code review, again, typically done for programming, is to identify code errors. These might be issues with data wrangling or analysis that might be problematic. And the goal of it is to reveal and remove those errors, as well as improve code and documentation quality. And our goal is that this ideally should build the analyst's skills and self-confidence as they both kind of provide feedback to their peers and get feedback from their peers. What we're finding, it's good, but it's still hard for undergraduates. We know that it's hard for people who are using Scrum in companies. There's a whole bunch of best practices in terms of code review. I'm not going to talk so much about that right now, but trying to think about how we can be scaffolding some of these experiences into our classes with some way of kind of structuring it so it's not so much of a surprise when people go out in the workforce and start doing code review but again, this is where we've been doing it in the project. So far, it's been a mixed bag of hard to get students doing this, but I think there's potential great benefit from it. So we've had all kinds of interesting results and challenges from the HDSR project. It's certainly been challenging to find appropriate projects where there's sufficiently large data and good questions that are tractable for students even in teams of 4 or 5 to be working. It's very difficult for the students to kind of develop the domain-based knowledge. That's one of the data acumen components, to be able to pose and answer questions. That fidelity to the Scrum structures is hard to maintain, quite frankly. That life gets busy and people start to kind of like not engage as much. And that's really difficult, particularly when you're providing peer feedback on something that might be problematic. So figuring out that accountability and structure is something we still need to be working on. That faculty support for this project is a big time investment. We have the NSF grant has been helpful, but again, it's the kind of thing that we need to kind of be thinking about structuring and organizing. There's a lot that we covered during the onboarding. Students' background, these are often sophomores or juniors, second or third year university students. Kind of getting them up to speed in terms of aspects of GitHub, aspects of Scrum has been challenging. And also there's struggles. This is a very different nature to a graded course. And so it's really a collaborative project where that team accountability is really critical. We've been working during the pandemic, and that hasn't made it any easier, though much of the work we were doing was already using Zoom. So I've tried to give a little bit of some sense of some of the things I've been doing that have motivated our curricular changes and other kind of approaches. My questions started off with this question of why are these methods so important for all students to learn? And again, I feel to a certain extent I'm preaching to the converted here. I think people understand that to kind of do this entire data analysis cycle, here's the Wickham and Grolman figure that we've seen already a couple of times, that to understand this and to be able to structure this in a way, we need to be thinking about reproducibility, that we need to be able to document and kind of see what's happened as we put together our analyses. Science kind of requires it. And I think it really is important for all students to understand that. You can certainly learn about aspects of p-values and the like in a course that didn't kind of take you through reproducible analysis. But I think that next level really needs to get you there. So what are the capacities we want them to develop and what are the skills we need them to master? I think these map fairly closely and well to those data acumen components. And so, from the NASEM 2018 report, those sub areas about workflow and reproducibility, data management, communication and teamwork, as well as ethical practice are the kinds of things that I think we all need to take in our courses and programs as a way to kind of allow that, that focus and background, because it does require repeated exposures and reinforcement over multiple years. When we think about creating multiple pathways for students, it's going to be hard. They're going to need to be picking up different parts and pieces. But I think we know that project and group-based learning can help in kind of evening out some of those gaps in knowledge and experience. What are the best practices for teaching these methods? I think we're now getting onto some pretty kind of shaky ground. I think it's very much a work in progress of what we have at present, that we need considerable research, as many careers to be done on kind of what are the best pedagogical approaches here. We know that the tools have been changing very rapidly. Both Jupyter Hub, RStudio, kind of have developed in recent years that have kind of helped to kind of make these tools much more easy and much more straightforward. But we need to develop, pilot, improve, then vet course materials, curricular modules. So again, it's the Wild West to some extent and great opportunities to be thinking about ways to kind of embed these in the curriculum. How could these methods be incorporated into both the K-12 and the college curricula? I think this is an area where there's a lot of work happening, particularly in the kind of pre-secondary world. The Concord Consortium and their CODAP approach, the Common Online Data Analysis Platform, really are tied in. It's science education is a lot of what the Concord Consortium does. And so the lab notebook metaphor and other approaches where people are building things in CODAP, I think is really valuable. And again, in college, early and often is the right answer. Bussberg argued that reproducibility should be in all courses to avoid students developing bad habits as well as reinforcing good habits. And I think by doing that right, we build skills that are needed for both workforce and graduate studies. And then I think it feeds into kind of innovative courses like what Janz, Sullivan, and McAleer have been doing, sometimes at the secondary level, sometimes at the post-secondary level. But we can allow them to go much deeper and I think kind of extend further in their graduate courses if they have this foundation, what I would consider to be a reasonable part of data acumen. All kinds of other ideas from that Toronto reproducibility workshop. There's a kind of a post on Twitter, what's preventing you from presenting results like this? It's an interactive website, lets you explore different specifications, robustness of results. We have Mina's talk from that same workshop about version control and why for students it's useful to learn a best practice and why for educators it helps in all kinds of ways in structuring our teaching. Last but not least, how do we assess how effectively students are using these methods? And this is another area where even more work is needed. I think we can start with the tier soup to nuts exercises. Those are great, but again, how do we understand whether or not students have picked those parts and pieces up? We did some really minimal things. We got pushed by reviewers on the GitHub paper that I mentioned earlier, that we were using just standards-based grading. You got points if you committed. You know, we can go far. We need to go far beyond just, yes, you commit twice, you get full marks for your GitHub usage as a team. There's some neat things in Nicole's paper, that 2015 paper, that starts to think about some of these aspects of assessment. But again, this is an area where I think there's a lot of work needed. So as I think about data science education more broadly, I've been motivated to focus on computational thinking early and often. And certainly in the introductory statistics course, how do you develop multivariate thinking? How do you develop data acumen? And how do you bring those things into place early, and then so you can introduce it, reinforce it, and ideally develop mastery? I've embraced simplified computational interfaces. So we've been teaching using the formula-based approach to Mosaic for our low-level courses, things like the tidyverse for later on. And again, the goal of this is to minimize the cognitive load and to kind of scaffold reproducibility. This is really what I think Amelia was talking about, to get students doing more powerful things early on using these tools. And cloud computing, to me, is one of the great equalizers. It's a way of minimizing barriers to technology. The cost for computing has dropped dramatically, and I think it allows us to deal with historical disparities in various ways. I think it's critically important, and this is, again, going to be hard to scale, to adopt high-impact practices, active learning techniques. Things like pair programming, group and project-based learning, they've been shown to be effective in kind of getting a deeper, more fundamental level of understanding and, and learning by students. And again, it's not going to be easy necessarily to make that all happen, but I think that certainly as we start to look at aspects of reproducibility, they fit really well with some of those goals. And obviously there's a ton of work. Again, I do feel like to a large extent I'm preaching to the converted. Faculty development and training is really important in these areas to get others on board to really be shifting the curriculum and changing the climate. I needed to make a shameless plug. There's so many great things I've been hearing about. If you're ever looking for an outlet for it, the Journal of Statistics and Data Science Education, formerly the Journal of Statistics Education, it's published by Taylor and Francis on behalf of the American Statistical Association. I'm proud to report that it's open access, but no author fees. And submissions on reproducibility workflow and other topics related to pedagogy for statistics and data science education are warmly welcomed. And again, that was my sense. I really look forward to the conversations and discussions that will be happening on the 23rd. Thanks.